Okay, all the defaults are backwards. So let's fix that. But before we can fix it, we need to understand what we're really talking about. So let's start with this class. Really simple, it's just got one member variable. So let's add a method. Again, nice and simple, just an accessor really. Except you wouldn't really write it this way, or at least you shouldn't. I mean, for a start, it's not going to mutate its member. So we should make it const. It's not throwing any exceptions, it probably never should. So we should make it no except as well. And if you want the object itself to be const expr, then the method should be const expr as well. But at this point, it's already starting to be dominated by all this boilerplate of things that really should be the defaults. It's getting really heavyweight to do this. And we can actually go further. For example, if we wanted to return that integer by reference, well, we can add that. But except we can't do that because it's a const method. So we need to make that a const reference. And now we've done that, of course, it opens up to, well, do you put the const on the left? Do you put the const on the right? And, you know, I'm a proponent of these consts, but maybe you can't decide, so maybe you do both. And now it's getting really out of hand. So there are actually people that like this. I mean, for bonus points, which other speaker here his hand is there? Well done. So maybe that's a bit too far, so let's just dial it back a little bit. But really what we wanted was just that return value and the name and any arguments. And everything else should just be built in. But even then, we've got some things we can play with. We could use training return types. Though I actually prefer that style. I've done another whole talk on that. I'm not going to revisit it now. But I think there's very good reasons that we should favor that. So really, we wanted to write something like that. And let's just assume I've convinced you about the training return types. How does this stack up to other languages, similar languages, like Swift, for example? It's actually pretty good. It's the same number of characters for func instead of auto. But some people think the auto is a bit too much. F#'s a bit better. It's one character less with fun. A lot of fun in that language. Kotlin's about the same. JavaScript, that's much more verbose. You've got to spell out the whole function. But I think Rust has got it right, down to just 2 characters for the function introducer. But in general, you know, they're all much the same. But we're getting a bit off track. You know, we started off talking about the defaults. So let's put together a little bit of a wish list. We want things to be const by default, no except by default, const extra by default, and I'm going to add in the bit about the training return types, because I prefer that. Let's assume I've convinced you. But it should be a short introducer. Remember, Rust has 2 characters. And I think, you know, it should be consistent with lambda syntax, because we will like that. Funnily enough, we actually had this in C++ already. It's called lambda syntax. With lambda, we write that example something like this. Nice and simple. The problem is the variable name there, that's the name of the variable that we're copying into. It's not the name of the lambda, which is inherently unnamed and unnameable. What if we change that? What if you could give lambdas a name? You'll go here after the lambda introducer, or the function introducer, but before the parameter list, just as we have now. So it looks quite familiar. In fact, doesn't that look remarkably similar to the other examples we looked at? We need to do a couple of other things as well. We need to allow it to be declared namespace and class scope, and then we can use it instead of functions and methods. But that gives us everything on our wish list. Not bad for just a simple change on something that's going to be consistent. But why stop there? If we're going to have a hard reset on function syntax, we can go a bit further. For example, we've got that empty captures list there. Now, global scope, or even at class scope, it's always going to be empty. Because, of course, you have access to globals anyway, all the time. Except what if you didn't? What if to use a global, you had to explicitly capture it? And that means anything that has side effects, you have to explicitly state in your captures list. Now, by default, functions are also pure. Think about it. There's some problems I'm glossing over, of course. Perhaps overloading could be solved by the overload set we looked at earlier. But I think it's something to think about. If you want to talk more, you know how to reach me. Thank you very much.